So let's continue with our second part of the data solution well-architected framework discussion. And this part, we are going to discuss three aspects of the framework, which is availability and disaster recovery. The second part is security. And the third one is performance, elasticity, and performance. When you talk about availability and disaster recovery, the first thing we want to discuss is availability. What is availability? If you are a customer and calling, let's say, your insurance company, high availability means there's always someone who will immediately answer your phone. If you have to be put on hold, that means there's no availability, right? So availability is achieved by providing more service party, like you have more instances. You need to define multiple instances, especially if the network is down or one instance is down. You should have other instances providing the similar service so that the whole service is still available. Now, putting to extreme of this multiple instance service model is the multiple physical location model. The AWS infrastructure basically is a global infrastructure. It's built around AWS regions and the availability zones. And the region is separated. Region is separated like 6,000 miles away from each other or something, or 2,000. I forgot the exact number. But then availability zone basically are separated, independent data center within each region. Right. This provides you with a multiple physical location in case there's like a flood or a snowstorm or thunderstorm, something like that, that availability zone is down. There are still other availability zone available in the region. So the instance running in those data centers are still available. Even if something happened that the whole region is unavailable, you still have other regions serving you, possibly with some kind of performance hit. Now, the other concept that's closely related with availability is disaster recovery. It means if your service is not available, then you should be able to recover as soon as possible. Just like when you, again, go to the same insurance company call, analogy. When you call the insurance company, most likely you will hear some music and the machine recorded voice will say, "Oh, someone will be with you in shortly," and this shortly can anywhere between like 5 minutes to 20 minutes. This minutes is defined as the disaster recovery time when some compute unit is finally available back online for you to work with you. So there is something called the RTO, the recovery time objective, which how many minutes, right? And then there's also something called the RPO, which is the recovery point, recovery to a state of so many minutes ago. The most common disaster recovery technology are like replicas, backups, restores. So there are three types of backup. One is a code. You will rebuild the system from backup. And there's also a hot backup, which means there are multiple active points of the system at any time. Anytime there should be at least 2 or 3, like when we discussed AWS Aurora, we mentioned that it actually has 6 backup copies of its data across 3 different AZ. So in case any AZ down, we should still have enough copies to restore to retrieve the full data set. This is what we call a hot backup. It's always on, it's always available. Somewhere between cold and hot, there's different flavors, different degrees of warm. You will bring a backup system into action with a small amount of lag. How much is the lag time? depends on how warm or how hot your worm is. What's your temperature? Is your worm is lukewarm, like the room temperature warm, or is like warm enough to burn your lips? Okay, let's talk about cold DR, cold disaster recovery. Generally, you will create a backup a snapshot periodically and store it somewhere safe. And when necessary, you will provision the compute resource and resume work. If your service is a single instance service, like EC2, right, you will define EBS snapshots. Or if you have a single AZRDS, you will define backups or stashups. They will be stored in S3, which is highly available. And if you have a single cluster, like a Redshift, it has multiple instances, multiple nodes. Still, you will take a snapshot and to store them in S3. And you can see that backup and snapshot is the foundation of any disaster recovery, not only for cold disaster recovery. All services have some form of a backup and snapshot. When you start any web service, always pay attention to the backup snapshot ability it has. Is it automated, or you need to manually do it? And usually, these days, there shouldn't be any web service that cannot automatically generate a snapshot. You should always have the ability to automate the backup generation. But at the same time, you should be able to manually take a backup at the time you want, at the frequency you want. And the other extreme, of course, is hot. It's always some work capacity ready, right? We talk about AWS's high available and reliable infrastructure, like S3 or Route 53 is always on. This is available globally. And some services, they are hot inside their own region, like Kinesis or Athena or Glue. If their region is on, they should be on because their endpoints are established in all availability zones within that region. So anytime you open up your web console, you should always be able to get into this service. However, one thing to note that when we say hot disaster recovery here, the service may be multi-active and always on, but the underlying data may not be. For example, in Thanksgiving Day of 2020, AWS's US East 1 region, the Northern Virginia region, actually have a Kinesis outage. And because CloudWatch uses Kinesis, so CloudWatch activity in that region was down on that day. That down means you can still log into CloudWatch because the traffic accessing CloudWatch is directed to other regions. Other region like Ohio region is taking care of the traffic to access CloudWatch functionality. But when you try to access the CloudWatch logs in the Northern Virginia region, you will not be able to do that because the underlying data is in Northern Virginia region and is not accessible. The service is active, is on, but the data is not available. So this is something you need to take into consideration. If you do need to access the data, then just relying on the multi-active feature of AWS is not enough. You may need to manually set up your application to copy the data over to a separate region. This is the case, especially for example, like Redshift or like Aurora. Aurora is always on, right? But always on only, like Aurora, especially Aurora serverless. It's always on, but always on only in that region. So if you want to make sure it can sustain the downtime of one region, you need to manually copy or create a sink to a separate region, which is a new feature called Aurora Global Table does. I think, but at this point, Global Table, I believe, is still under preview. So once it's available to the public, it's generally available, then Aurora can be truly multi-active. Okay, so somewhere between cold and hot is warm. There are different levels, different temperatures of redundancy. The simplest, the coolest of the warm is a single cluster node recovery. For example, Redshift or EMR, they are single cluster multi-node services. Redshift can have multi-nodes, EMR can have multi-nodes, and they have redundancy inside their cluster. If a node is down, then they will automatically provision, when I say late, I mean the cluster will automatically provision a new node and copy the redundancy data into the new node to make the functioning. But it will take time. There will be like 10 to 20 minutes that the cluster is not available, not accessible. Further warmer than this single cluster node recovery is a single AZ multi-master with failover of EMR. So in EMR, you can define multiple master. You can define 3 master nodes in one cluster. If a master node is down, the other 2 masters can recover the same master, so make the cluster available. But of course, this cluster will still be down if the whole availability zone is down. So there's also something like single cluster multi-AZ with failover. For example, the multi-AZ RDS. The multi-AZ RDS have a multi-AZ deployment in a multi-AZ availability zone. If availability zone is down, then the RDS instance in other availability zone will take over, becomes the main RDS instance. And also you can have an asynchronized replica, which can be promoted to the master node, like RDS read replica. And finally, we have a multi-active asynchronized and multi-active, like DynamoDB global table. It is a multi-active one. It is a multi-active. You can access the same table in different region, and the change will be populated across all the regions. However, it will take a while. When you write something in Northern Virginia, it will take a while, maybe in tens of milliseconds, for the change to show up in Ohio region. But it's definitely better than a single class node recovery, right? So there are different temperature, different levels of redundancy, and different levels of disaster recovery. Whichever you choose depends on your need, and you need to, when you start a certain web service, you need to see what options it has and how this is achieved. Okay, so these are the disaster recoveries. Now let's discuss security. Security in AWS context means 3 things. First of all, is the network accessibility. You need to access the web service. You need to be able to access the web service through the network. The second is authentication and authorization. Once you can contact that web service compute unit, you need to let the compute unit allow you to perform certain operations. And finally, there's encryption. Encryption is the storage side. That data is stored, whether they're encrypted, and when you pull it out, is that encrypted? So we mentioned the networking between different compute unit in our previous session. if a service exists inside the VPC, it will be able to communicate with any other resources in the same VPC. And the traffic will be inside AWS network. Now, you can on top of that, you will use security group and NACL to control access. Security group is something that will allow and the network traffic to a specific range of ports in the network interface. And this is important because it explicitly tells you security group exists on network interface. So it's only attached to services that has a network interface. If the service does not have a network interface, the service will not be using a security group. So this is the case for DynamoDB. DynamoDB does not have a network interface attached to a VPC, not at least at this point, January 2021. So whatever security group you define, it will not affect DynamoDB. Now for service existing outside of a VPC, if it has a VPC network interface, we mentioned that if for services outside of a VPC, you can either define a network interface or define a private link or endpoint or both in order to communicate with the VPC. And these are both of them are one direction. You can use the network interface to access resource in the VPC. Then the resource in the VPC can use the private link endpoint to access the web service. Like a VPC gateway endpoint for S3 DynamoDB or VPC interface endpoint for Glue. Now traffic, if a service does not have a network interface or endpoint to the VPC, right? Or a resource outside of VPC try to access another resource outside of VPC, like QuickSight is defined outside the VPC and Athena is out of VPC. The traffic between QuickSight and Athena will not go through VPC, will not go through AWS, will not necessarily go through AWS network. It will still be secured using SSL TLS, but the traffic will be on public internet. Or sometimes if a service does not have a network interface endpoint to the VPC, for example, QuickSight use public IP compute units. So if when you retrieve your data from QuickSight, either you are in your on-premise network or on VPC, the traffic still goes through public website and public network. If you want to make sure the network must be staying inside AWS network, you have to design other approach, maybe changing some kind of a network protocol or move instead of a QuickSight using some other hosted solution inside your VPC. So this is definitely the issue, a concern. I already talked to AWS support and they have already logged the feature request so that we can control whether the traffic will be on public internet or stay inside AWS network. But I think they eventually will fix this or will come up with some feature to address this issue, but definitely not anytime soon. And before the solution comes out, we still have to pay attention to where the network traffic goes, whether it's a public internet or not. Right. And the other side of the story is when you try to use AWS service, you should also pay attention to how you communicate, private communication between your AWS and the on-premise network, because your work machine you likely will be on your data center or your office building inside your on-premise network. Then you will use a VPN or use the direct connect. And remember, direct connect's maximum bandwidth is 1 gig or 10 gig. All right, so these are the network considerations. How network are going and how you connect different components, how you make sure they stay inside AWS network and not going through public. Some company may have a requirement that their network traffic cannot be on the public internet. Then for these guys, this unfortunate projects, you need to take a consideration on the network configuration and probably choosing web services accordingly. The second aspect of a security is access control. Every AWS resource is owned by an AWS account, and the permission to create or access the resources are governed by policies. Oops. An account administrator can attach policies to IAM identities, and some services also support permission to resources. But in general, I do recommend you to only use IAM identity policies whenever possible. Resource-based policy, when mixed with IAM identity-based policy, can cause a lot of confusion and can make your security model really complex. So this has to be a last resort if you still cannot resolve it. But to be honest, I haven't seen any scenario that you have to use resource-based permission policy yet. So try always use IAM identity policy to simplify your model, your security model. The authorization authentication, the authentication and authorization process of AWS is first, the client, the user, must be an IAM user. Then it must be get authenticated. Either use a username, password, or key secrets. And finally, resource will check authorization policy of client to see whether client can access the resource or not. That means check the IAM identity policy of the client to see whether they can access the resource or not. A policy is a set of actions that you can specify. You have to specify which resource, which action, which effect, and which principle. So it's basically some IAM user or role can perform certain action on a resource. Either you can allow it or you deny it, you cannot. And apparently, and I think everybody knows what a user is. It's basically an account that can access the resource on. You can also use a role to group a collection of AWS policies. And this is actually the recommended way of supplying security credential. Always try to use role instead of use user or user group, right? And the one important aspect is called identity federation. Identity federation basically means you utilize an existing identity system outside of AWS for the authentication inside AWS. You can use like Active Directory, usually is or Okta. These two are enterprise identity solutions, or like group or Facebook, Google or Facebook identities. And the protocol you utilize is SAML or OIDC, and you use single sign-on at IAM. So these are the user part, access part. These part are often seen. There are like actually always probably like I'm quickly calculating probably like 3-4 questions in every exam for this access and authorization thing. Another important aspect is encryption. Encryption means how you make your data secure. There are two states of encryption. One is in transit. When you transfer the data over the network, you will use what they call a secure sockets layer, or the transport layer security, which is often written as SSL and TLS. These two are two different protocols, but they have so much overlapping, and the part that they overlap, they're almost identical. So these days, anyone who supports SSL will also support TLS, and vice versa. So people always write them as if they are one part, SSL/TLS. But note, utilizing SSL/TLS may not necessarily be the default. So if this is not specified as default, then the data is transferred over the network without encryption in plain text. Anybody can catch the packet, can read through and see what's inside. However, this does not mean that you need to encrypt every traffic, because SSL and TLS is actually a relatively expensive operation. So you need to consider the cost before opting. In the typical layout, you will have an internet, web server, RDS connection, right? And you can see I put a pipe here. Use this pipe to signify where you can terminate the SSL TLS traffic. The traffic over internet to web server apparently must be encrypted, should be using SSL and TLS. However, usually the web server, both web server and RDS will be in your network. So do you need to apply SSL and TLS between web server and RDS? This is a question based on your requirement, eventually based on your requirement, but not necessarily, the answer is not necessarily that you have to enable. If you think your internal traffic is secure, internal network is secured enough, then you can terminate the RDS, the SSL on web server. The traffic between web server and RDS can be plain text. Or sometimes if you have a load balancer in front of a web server, then even the traffic between load balancer and the web server can be plain text, right? It can be between load balancer and web server and RDS. But of course, eventually this depends on your security requirement. The other state of encryption is at rest, meaning the data stored in the storage. And usually we will use a key to encrypt the data. There are three types of custom master keys in AWS. One is what we call the AWS owned CMK. This is owned by AWS by default. So technically, if you use this key to, AWS can see whatever your data is. AWS managed CMK is you will pick a key, you will supply the key. It is stored in your account and is managed by AWS KMS. And finally, there's a customer managed CMK. The key is stored in your account, is created, owned, and managed by you. You will have a full control over the CMK. You can also encrypt all your data using your own tool before sending them into AWS. So this is usually due to legal compliance requirements that you have to encrypt. But generally, this is very expensive. So my recommendation would be don't do that unless you are required to do so. So, but in that case, you will decrypt and encrypt the data in all of your applications so that anytime the data goes into AWS network, it's already encrypted. When the saved is encrypted and the key is controlled by you, AWS will not be able to see it. So this is the extreme case of encryption at rest encryption. Okay, the final aspect of a well-architected framework is elasticity and performance. Elasticity provides the right amount of resource at any given time. So you look at this chart. This actually comes from Google Cloud, a competitor, not AWS. But this tells you what may happen when you illy prepared for traffic. This is actually the transaction for a very popular cell phone game, which is actually Go. So originally, the Pokemon Go team project the usage will be this orange line, and in anticipating popularity, they prepared for the worst case, which is in the red line. And as you can see, they have a very happy problem that the actual usage goes all the way to 50 times of their targeted traffic. So of course, if you have this issue, this is a very happy issue, right? But then if your users cannot access your service, then there's some issue with your reputation, right? So that's when you need elasticity, where you can dynamically supply resources when needed. The underlying infrastructure of elasticity is to define multiple processing units. Either you use multiple nodes in a cluster like Redshift and EMR, or you use multiple shards in the service like Kinesis. And you can change the number of nodes shards. Then you can achieve scalability. If in this case, let's say if it's EMR, and originally the EMR nodes has a one node, then by increasing the node count to 50, you should be able to handle. Of course, this is, as I said, this is actually something from Google Cloud. It's not the same, but the idea remains the same. And you can manually change that. You can have someone looking at the CloudWatch metric chart. As soon as the CPU usage goes up, this guy will add a node to the cluster. But of course, this is just an extreme case. What we usually do is we will do auto scaling. There are two types of scaling. One is you will user-defined auto scaling, which means you have a code. You write your code to monitor the CloudWatch metric or some other things, but the most part, in most cases, it will be a CloudWatch metric. If the metric like CPU usage goes above 60% or 70%, then your code will provision either Kinesis shard or a node. Or maybe the web service, latest services always comes with auto scaling of their own, like Aurora Serverless or DynamoDB on demand, right? Let me show you. When we define Aurora Serverless, you can see that the capacity setting, it's already provides you with a minimum and a maximum. So Aurora will monitor the usage of the performance of your system. If the performance deteriorates, it will add capacity unit. If the workload decrease, then it will decrease the capacity unit, right? And for the EMR scaling, you can also define units or nodes that can goes up, goes down depending on the performance. Or if the service does not comes with auto scaling like Kinesis, then you have to write your own code. But here is the AWS blog teaching you how to use AWS application, which is a Lambda function, monitoring the CloudWatch metric and provision Kinesis data stream shards or decrease the number of shards so that you can achieve auto scaling. So these are two types of scaling. Another way of scaling alleviate some of the work is by using read replica. It's a kind of a separation of duty that you have the master node doing the write, the insert, and you have the read replica serving the need of read, because in general, data only get written once, but it will be get read multiple times. That's where this read replica idea comes from, because read workload usually is much higher than write workload. So why don't we just reserve one master node for write and have some replica for read? This is widely used by RDS, especially Aurora, but it's also widely used by other services like Neptune and DocumentDB. It is asynchronized. It's not designed for hot backup. But if you want to use a cheap solution, but warm backup solution, it can serve the purpose too. And finally, there's always all sorts of caching services, right? You have an in-memory database like ElastiCache. You have DynamoDB DAX, etc., depending on the exact service. These are two most popular caching services that you can utilize to help you achieve your performance goal. So far, let's take a quick, we have finished all the topics we want to cover in this advanced discussion. Let's take a look back at the well-architected framework, the operational excellence, how do you make sure the system is running smoothly, and then security, how do you ensure the security and reliability, and then followed by performance, efficiency, and cost optimization. And we go through the physical implementations, and we go through 4 different aspects. So, and this concludes our data solution overview. Thank you very much, everyone.